In this video, we're going to cover functions, and a function is essentially a set of instructions that can be used to repeatedly do a specific task, and we can call it over and over and over, and it allows for us not to repeat blocks of code, because if something changes in that block of code, that means if I had 10 instances where I was calling a function, if I was not using a function, then I would have 10 blocks of code that I would actually have to go update. So this allows for more of a modular code usage where we can generate more maintainable code. And one of the things that you always want to do is generate maintainable code. You certainly don't want to generate thousands and thousands of lines of code that are hard to update because you're repeating the same blocks of code over and over and over. Now, I have seen and witnessed in industry that this has happened where somebody has not used functions and they just kept repeating the same blocks over and over and over, and have actually gone through and did a refactoring of this code. And refactoring means you rework it so it is much more reliable and robust, and eliminated over 1,000 lines of code for this person. So that was 1,000 lines of code that had been repeated and wasn't using functions. And I asked the person why they had done that, and they said, it was just easier for them to understand instead of creating a function that has a really well-defined name that gives meaning to what is actually being accomplished within that particular method. A little bit interesting, but it was something that got reworked because it wasn't sustainable for production code. Now, when we look at the format of a function, it is going to start with the keyword func, followed by whatever user-defined function name that you'd like. And notice that they show this in the book in camel case. It's going to have a parameter list, and we'll take a look at the parameters, but there can be 0 to many parameters. We don't have to necessarily specify any parameters within that parameter list. It's going to have a return type, and even though we may not specify a return type, there is an implied return type in that case, and we'll hard code it out so that you see what that would be in the case where we don't return anything, but we want to see what that looks like that they're implying there. And then our function is also going to have that body of code that we generate that's going to do things over and over and over. So when we look at the format, we're going to generate an initial function, and then we're just going to iterate over the process. We're going to do things where we're adding parameters. We're going to add some argument labels. We're going to omit the argument labels, so we'll take a look at that. That allows us to do things where we're doing more of a positional calling of the method if we omit the argument labels. We also have the ability to specify default parameter values in the event that there is a situation where it makes sense to have like a default value. If somebody doesn't pass it, it's just inferred that this is going to be the value. And then we also have return types. So when we create a function, we can return something from that function, and our functions return types that we know about now, because we haven't gone further. We'll go further in the class and we'll see other types that we can return, but we can return the strings, we can return the bools, etc. all the different types that we've been learning about thus far. At this point, I want to go ahead and get out of the presentation, and let's go ahead and get into doing some code. I have a file that has already been started, that has an existing set of code in it that we can start with, and I'm going to go ahead and open this. I'm going to call this functions.swift, and if I bring it over from my other screen, we essentially see that we have a series of variables that have been defined, so prefix, suffix, first name, last name, and then a greeting. And we're going through and we're essentially checking to see if those fields are empty, and if they're not empty, then we're going to do some concatenation. So if our check for the empty is taking whatever the field is, in this case we have the prefix, and using the method on that, the isEmpty, and that's going to return whether it's empty or not. And then we're inverting that value by using the not condition to check to see if it is not empty. And then if it's not empty, then we're doing the concatenation, and we're pretty much doing it all the way through our prefix, first name, last name, and suffix. Then when we get down to the greeting, we may have a situation where they didn't have a suffix, but we've gone ahead and appended a space at the very last end, so that would be considered white space that we want to trim off because we want to put an exclamation mark, because not everybody's going to have a suffix like junior or senior, etc. So we want to go ahead and trim the ending space, and in a lot of languages we have some type of a trim function that's available that can trim that white space. In Swift, we have this trimming characters that we have to tell it what we want to trim. In our case, we want it to trim the white space, so we're going to tell it white spaces. But in order to use this trimming characteristics, we have to bring in this import statement to import the foundations, which this particular function is part of that library. Once we do that, we're basically trimming the white space and reassigning whatever the result of that operation is to our greeting, and then we can append that exclamation mark and print out our greeting. So this is our program to start with. This is what we're going to iterate over, and we're going to move it towards a function, and then we're going to refactor the function until it is in different representations. So we'll be using named arguments. We'll start out with no arguments. We'll change it up and add some default parameters and some return values, etc. So we're going to just iterate over that function, just working through how we can define functions here. So I'm going to go ahead and save this, switch back to my terminal, and over here I'm just going to go ahead and run it. Make sure I'm in the window. And pretty much we can see that it's taking every field. So I had a prefix of Mrs., I had the first name of Jenny, the last name of Kunkel. I didn't have a suffix, so that extra space that was added at the end was trimmed out based on this trimming characters, and then I added that exclamation mark at the end. So I have, hi Mrs. Jenny Kunkel. Now what happens, and I'm going to switch back to the code portion, if I decide I really have multiple people that I want to greet, and in this case I'm going to go ahead and create another set of values. So I'm going to change my prefix, and in this case I'm going to change it to doctor, and I have a first name, and that's going to be equal to John, a last name equal to Ryan, and then our suffix is going to be equal to junior. Now if I want to print out the same greeting, I would have to copy all of this code, and this is where we get into duplicating blocks of code, which is really a bad thing in programming. And I'm going to paste this in here. And of course I have to fix my greeting because we're going to be reusing that variable. We don't need to redefine it. That would cause us a syntax error. And we're going to go ahead and write out the greeting for Dr. John Ryan Jr. So if I go ahead and save this, when we go back to our command line here and run it, we should see that we have both greetings. But as I said, this whole practice where we're duplicating the code is a really bad practice. And we don't like to do that. And for our first iteration, we're going to actually comment out the code down below that we just added. We just want to iterate on the first block. We're not going to be passing in any variables, and we're going to be using global variables within the program to actually get the information out of the fields so that we can write stuff out. Now in this case, when we do that, using globals is really a bad practice, and in a lot of cases, we're not going to have access to a lot of different fields in our programs because it's going to be coming out of our form fields that we're using when we define them within an application, and we're not going to have a bunch of variables sitting along in our inline code like this. But to show this initially, we're going to create a function and use those global variables. In our case, this is going to be defined when we start it as a function. We use the keyword func. We give it a really descriptive user-defined name that describes what is going on in the function itself. And in this case, we're going to be creating a greeting. So we'll call it create greeting. And initially, as I said, we're going to get our information from global variables so we don't have to pass anything in. So our argument list that we're passing in does not contain any parameters. We have an implied return type of nothing, so we don't have to write any return type. We'll fix it up when we come back and show what it would be if we explicitly wrote what the return type would be. And then I can put my ending brace to indicate that this is the block of code that we want to execute. So anything that I want to execute multiple times, I would put it in a function in the block of code and ensure that that particular block of code is only trying to address one thing. Now, I need to be able to call this function in order for it to execute the code. Because right now I have the function. If I ran the program, it would do nothing because I haven't called that function. And in order to call the function, if I start typing, it's going to bring it in. And essentially, I just call the function name and provide its argument list since we don't have a return type. If we had a return type, then I would want to capture whatever is being returned from that function and store it in a variable or a constant. It could be a constant. But in this case, let's go ahead and let's see that we have essentially the same thing that we started with. Control S. And if I go back to my terminal window, I should probably have them a little bit staggered so I can see them. I can go ahead and execute this, and we can see that we have the same result. So that's good. That's what we want to have happen. But that implied return type, when we don't specify it, how can we explicitly specify and understand what it's doing under the hood when we don't specify it? Well, it's returning what we call a void. In a lot of different languages, and we would capitalize the V in void, we have a void type that when we don't return anything from a function or a method, and when I talk about methods, that's in the context of object-oriented. It's the same thing as a function, we just name it differently when we're in that context. When we return nothing, we specify a void in a lot of languages. Now here they're making it easy. We can just leave off this part right here when we have nothing to return. But just to show that it's going to do the exact same thing, I can come in here and execute it, and it is going to return the very exact same thing. Now, as I stated, in a lot of cases, we don't do the globals. So the globals are outside of our function. Now, if I have my greeting here, and we'll look at this in a little bit, this is local. So this is defined locally to my function, and this value of greeting that I create doesn't exist after this function terminates. So when we hit this curly brace, when it's going through and processing the statements, when it sees this curly brace, that variable gets disposed, and we can't access that value anymore. So that's kind of one of the things that if we define something within a function, after we hit this point, we have no longer the ability to access that information. So in a lot of cases, that's where we come in with return types, because we want to return the value. So maybe instead of printing the greeting from within my create greeting, I just want to return it because maybe I'm going to do something else with it and I'm just not going to print it and I want to use it for some other purpose. If I want to change the return type and return a string for my greeting, so I just want to return this greeting that's essentially a string of all the concatenated stuff, I would come up here and change the void to a string. When I do this, I'm going to return, because I have to tell it what I'm returning from this, and it has to be of the type that I specify. I would come in here and create a variable of an integer, and I would try to return the integer. When I have my return type of string specified, it would error, and I would have some type of syntax error when I tried to run the program. So in this case, I'm going to return my greeting. And when I get done here, if I don't do anything and capture the result of that, and we should always be capturing results, if I don't capture it, I'm going to get a warning. So I'm just going to save it this way so we can see what that looks like. It's going to execute the function, but we're not going to see anything because it doesn't print anything out. So it gives me this warning, but it doesn't do anything. Now, how do I know that it's actually executing this? Because I could actually put something after here and I could see that it's not crashing the program, because if it was going to have a syntax problem, it would not run any code. So I could put something like print here, and I can see that it's actually made it through the execution of the function. It just hasn't failed because of the syntax error. Okay, so if I go ahead and rerun this, we can see it's printing here, so we know it's executing the code. It's not just generating that syntax. It was just a matter we're not capturing anything back from this method, so it's not printing anything out. Now, I'm going to go ahead, and in the main program here, I'm going to go ahead and create a message, not to be confused with the variable that we defined. And it could be a greeting that I define here, but I'm going to just go ahead and make it a message. And I'm going to output the message that's returned. So we can see that we're actually capturing the results that we created the greeting here. We're returning that greeting, we're capturing it as a message, and then printing the message out here. So if I go ahead and save it, and I come back in here and rerun it, we can see the greeting that was returned, and we're printing out as a message. So that's how we can use return types. Now, let's address the parameters. So in a lot of cases, we have 0 to many. This is the case where we have 0. We don't have anything that's specified within our parentheses as a parameter list that we're calling this method with or expecting to use within the method as input data. Now, we only pass things as input data that we can't determine from outside of. When we get in here, we're going to define the prefix. So I'm basically just going to shortcut and copy some of this data here to save time. So I can put a parameter here for the prefix, comma, the parameter for the first name, the parameter for the last name, and then the parameter for the suffix. When I specify my parameters, I'm going to specify them with the variable name that I want to use referenced in this particular method here. So in this case, I'm using whatever's being passed to the method for the prefix in this particular function as prefix. So I would refer to that data that's coming in as prefix here. It's going to have a type of string. In a lot of languages, it's flipped, and we have the type before the actual parameter that is being passed in. In this case, we are using the parameter name, and which is, in their case, they're talking about labels, the argument label, and then the type. So we have an argument label here and the type, and an argument label here and the type, and an argument label here and the type. It's still going to return our string, but in our case now, and let's change this a little bit here so it's pretty understandable that we're passing in something other than just employee. It might get a little confusing if we pass in something that's using the same name. We can certainly do that. So I can pass in my prefix variable for this argument label of prefix, but let's make it so that it's more apparent what we're doing. So I'm going to call this emp prefix and change this to emp first name, emp last name, and then emp suffix. Now I can go through and on my greeting, if I come down here and remove it, I'm going to create greeting. Now notice it's bringing in all these fields. So it's giving us the argument label, and then the string is what we replace it with. Now we could actually hard code a string value, so I could put in within double quotes Mrs., or I could use my variable here. So I'm going to pass in the variable. Oops. Going to replace that string though. Copy this, paste it in as the first name, copy the last name, replace the string, and then on our last, copy our employee suffix and replace the string here with that. So essentially we have our argument label of prefix, and the prefix is what we're using within our method, and we're passing in our variable that is currently a variable that we've defined within the program outside of the function, and that's going to be the emp prefix. And we're doing the same thing with the first name, the last name, and then the suffix. If we go ahead and save this, what we see is we have, hi, Mrs. Jenny Kunkel. We had where we were changing out and adding another, so let's go ahead and let's copy this and remove it. So I'm going to get rid of that and paste it right here after I define these things. And I want to call this again, so I'm just going to go ahead and copy this block again and make sure that I fix it up correctly, because if I don't, then I'm going to have errors. So I need to remove the var, because I'm not defining a new variable and I don't want to specify the type. I just want to reuse that variable and print out the greeting for the next set of information. So I can go ahead and save this, and we should see that, oh, I changed my names, as you can see here, so I need to update my variables here. You probably were understanding that that was going to happen. Sometimes it's hard to talk and stay focused about what's going on when you're recording stuff. And then we have our emp suffix. So this should work now as we do this. That's what I get for changing the variable names. Now if I run it, it should work, and we have both of the greetings. And that is really nice. But in a lot of languages, we use positional parameters instead of named parameters, because these are pretty much named with these argument labels, and then we're specifying what the variable is that we're sending in. It doesn't mean that we can start mixing up the order of our parameters. If we would try to mix them up, it's going to have a little bit of a cow. And what I mean by that is if I decide that I'm going to move this and place it at the very end, it's going to have a problem. So even though we have these name parameters, they have to be in the same order. Now in other languages that we have name parameters, we okay with putting them in any order, but that's not the case with Swift. And I'm just going to undo and put it back. We have to put the parameters in the same order, even with these argument labels. But what if we want to make it so that we can call these methods more like normal procedures and functions that we see in other language where we're passing in just positional parameters? We can do that by changing and using this underscore space before our argument label. And if I come back here, and I'm just going to comment out this last one because I don't want to call this last one here. I'm going to change this up, and I'm going to remove the prefix, remove the first name, because this is what this allows us to do, remove the last name, and remove the suffix. So we're basically just passing in the values that are going to map. So this particular one is the first in that's being passed in. It's going to map to the prefix. The second is going to map to the first name. The third's going to map to the last name, and then the fourth is going to map to the suffix. Now we lose a lot of the readability because we have to know explicitly what the first parameter is, what the second parameter, third, and fourth are when we do this over something that's more readable where we can understand what parameter or what variable that we're using in our program is going to be used as the prefix in our function that we call. So that's way more meaningful as far as the readability of a program. So let's go ahead and save this. And if we rerun it, we should see the exact same thing. But now we don't have our argument labels that we're using to pass in the information. So that's one thing that we can do. But what happens if we decide that in some cases, I want to go ahead and I want to set up maybe some default. And maybe we have 80% of the company who are male, and we want to do some type of a form letter where we're sending out this greeting. And I want to go through, and by default, I want to pass in and set a default of Mr. And only when it's not a male do I want to send in something that would be alternative. In this case, we're going to send this equal to MR period. Okay, so that would be our prefix that we're defaulting to Mr., which means that then we could actually eliminate the emp prefix from being passed in if that case was that the person that we were executing it for did not have that value. Now we could also possibly, since a lot of people don't have suffixes, set this equal to an empty string. And only when they have a suffix would we pass in that value. If we do this, I'm going to go ahead and leave my employee prefix because we can still pass in our prefix, but take off this. Is it going to work? Do we think it's going to work here? Yes, it did. It's essentially going to take the three different things, because we're passing in three values, and it's going to assume that the very last one is going to be the suffix. Now, we couldn't get away with that necessarily with the employee prefix without specifying something here in a little bit more detail. It's much better in the case of these when we have optional parameters to actually leave the named label so we know which one we're passing in. And I can go through and remove this. So we're going to have the named labels that we're using of the arguments, and we're going to be assigning them default values. Now in this case, then I would need to pass in my prefix and tell it what. And if I went ahead and ran this, I could see that it's still going to work. Now if I want to come down here and I want to change up this greeting down here, I have my prefix that I want to pass in because it's a doctor. I have my first name, my last name, and I want to override the suffix too. Well, in my first name, I wouldn't be passing in that. I would just be passing in the value that I would assign, and then the value for the last name as well. The only things that we need to provide the actual argument labels for are those things that don't have the underscore, and we have no underscore here, we have no underscore here, we have an underscore here, and if we go ahead and save this, then we can go ahead and see that now it's going to print out both. But what happens if we don't want to necessarily use that prefix, and if I leave that one out at this point, and I save it, does that work? And it does. So this kind of should give you a little bit of flavor for using those default values in combination with those argument labels that we omit. So those would be the ones that have the underscore. And then also using the ones that have the label. And as I indicated, those, when we're using the omitted argument label, that's much more like what we see in other programming languages. However, using those argument labels is going to provide us with more readable code, so that would be the recommendation, is to use them instead of using these omission of the argument labels. If you have any questions on any of this, please feel free to reach out to me.